Hey everyone, moving on to the second last technique of our graphs and transformations, we have the modulus graphs. And I've already explained how modulus graphs comes about, but I'll need to teach you how to actually write down the specific transformations for the different modulus graphs. And we have y equals to f mod x and also y equals to mod fx. Alright. Now these will mainly be the modulus graphs that we'll be sketching. There won't be, if I'm not mistaken, g mod y and all that, so don't worry about those, but again, those are the same idea here. So I've already gone through modulus, so if you want to learn about them, do look at the other video before continuing here. Otherwise, I will just proceed with writing down the sequences of transformation. And we start with f mod x. So we know that f mod x, basically your negative values would get the same values as the positive side, which means one thing: anything that's at the positive side would undergo a reflection about the y-axis. And before we do that, we need to delete the negative x region, because when you get rid of the negative, whatever we have in the negative x region, to retain and reflect. So the keywords delete, next one is retain and reflect the positive y region about the x-axis. Oh, sorry, y-axis. And that is how we obtain the f mod x graph. Alright. Conversely, if we have, let's say, y equals to f minus mod x, then we know that the input is now always negative, which means the negative value for x would be the same for the positive x side. That means instead of deleting the negative x region, we will now delete the positive x region and then retain and reflect the negative x region again about the y-axis. Alright, because as I already mentioned just now, your positive x values would give you negative x values, and therefore you just need to delete whatever's in the positive x value and then reflect the negative x value. Now we move on to our mod fx, and also later on y equals to minus mod fx. Alright, so mod fx, basically every part of the negative value would become positive, so any value that is down here would get reflected upwards, and you notice that it will be about the y-axis, x-axis. That's all. It's actually quite simple. It is just a one-step transformation. You will just reflect the negative y value or negative y region. We can even reflect the points below the x-axis about the x-axis. Alright, and there you go. That will be y equals to mod fx. Similarly, if we have y equals to minus mod fx, whatever value that we have on the positive side must become negative. So our positive value become negative. Now we reflect the positive y region about the x-axis. And that is simply the modulus transformations for the H2 Math syllabus. Alright, and again, how it works is pretty much the same all along. If you apply the mod to x, it will only apply the modulus to every x variable, which means that if you were to translate and then mod, your translation won't be affected. But if you were to mod first and then translate, your translation would be inside the mod. And I'll go through that when we talk about the final version of the combination, where we include the idea of modulus inside as well. Alright, so that will be the next video, and I'll see you guys then.